Righto, Year 10, I'm just going to go over some of the questions on binomial distribution of surds. If you're away, you were meant to do 11, 12 and 14 last column. There is only one column for 11, but I will do two of the questions from 11. I want you to do 11b on your own, and I want you to try 11c before you see my solution. So this law that we're going to use for this, we did in class the other day. It's called the difference of two squares. So 11 just uses the difference of two squares. Let's have a look at 11a. And we've got root 2 plus root 7 times root 2 minus root 7. Excuse me. So what do we got here? Well, all we have to do is write this as a difference of two squares. My first thing squared, root 2 squared. Well, root 2 squared is 2. Minus the second thing squared. Well, root 7 squared is 7. And 2 minus 7 is negative 5. Now it's pretty easy. We're going to do f. You should have a go at it on your own before you watch this. And, sorry, not f, c. So c, and I've got 5 root 11 minus 7 root 3, and I've got 5 root 11 plus 7 root 3. Now, before you jump up and down, it doesn't matter which one you do first, whether you do that multiplication first or that multiplication first. It does not matter. So the fact that this has got the minus 1 first, it doesn't matter. They're two things multiplied together. It does not matter. So this is just going to be the difference of two squares. So here we go. The first thing squared. Well, 5 squared is 25. But root 11 squared is 11. And the second one, 7 squared is 49. And root 3 squared is 3. 5 times 11 is 275. 3 49s, well that's 3 50s minus 3, so that's 147. And then when I do that subtraction, I get 128. So 11 is pretty easy, difference of two squares. Our second one, however, 12, is going to be just a normal binomial expansion. So I'm going to do 12a, and then I'm going to do 12f. So I've got 3 minus 2 root 7 times root 21 minus 4 root 3. Now, normally I wouldn't write all this out, but that's only because I've had lots of practice. You might need to write all this out when you do them. So I'm going to do my expansion, 3 times that and 3 times that. And I'm going to do minus 2 root 7 times that and minus 2 root 7 times that. Well, 3 times root 21 is 3 root 21. 3 times minus 4 root 3, well, that's going to be minus 12 root 3. And this is what I mean when I'm going to write it out. So I've got minus 2 root 7 times root 21. And I've got minus minus, so I get plus 2 root 7 times 4 root 3. Well, 3 root 21, that's all right. I can't do anything with that. 12 root 3, I can't do anything with that. But when I look here, I know that root 21 is root 7 times root 3. So when I do this multiplication, I get 2 times root 7 times root 7. Well, root 7 times root 7 is 7, and 2 times 7 is 14, and I get a root 3. And here, 2 times 4 is 8. Root 3 times root 7 is root 21. Now, I've got 3 root 21s, and I add another 8 root 21s. That gives me 11 root 21s. And I've got minus 12 root 3s, and I'm minus another 14 root 3s. That gives me minus 26 root 3s. And if I look at 12a, 11 root 21 minus 26 root 3. All right, let's go all the way down to 12b, 12f, because you need to have a go at 12b and d on your own. They're just expansions. So here is 12f. And what have I got? I've got 5 minus 3 root 2 and 2 root 10 plus 3 root 5. Now again, I don't write out all the expansions, but that's only because I've done them lots and lots. You might need to write out all the expansions. So here I go. 5 times 2 root 10 plus 5 times 3 root 5 minus 3 root 2 times 2 root 10 minus 3 root 2 times 3 root 5. Okay, 5 times 2 is 10, 10 root 10. Easy. 5 times 3 is 15, 15 root 5. 3 times 2 is 6, but this root 10, I can write this root 10 as root 2 root 5. So now I'll get 3 times 2 is 6, root 2 times root 2 is 2, 6 times 2 is 12 root 5. That's a tricky bit, that one. Here, I'll get 3 times 3 is 6, and root 2 times root 5 is root 10. Let's tidy that up. I've got 10 root 10, and I take away 6 root 10. That leaves me with 4 root 10. It's crazy. 3 times 3 is 9. And 10 minus 9 is 1. That was a bit silly. Now, I've got 15 root 5 minus 12 root 5. Have a look here. 15 root 5, I take away 12 root 5, and that gives me 3 root 5. Finally, let's have a look at question 14. Now again, question 14, I'll do B and H. You have a go at the other two, but have a go at H before I do it. So 14B, what have I got? Root 5 minus root 3 all squared plus root 5 plus root 3 all squared. Now, these ones are going to use these rules. A plus B all squared is the first thing squared plus 2 times everything plus the last thing squared. But we've also got a minus 1 there, and A minus B all squared is the first thing squared minus 2 times everything plus the last thing squared. So let's go back. And what have we got? Root 5 squared is 5. I'm going to put this first thing in brackets. I'm just going to do the expansion of this. 2 times everything, and it's minus 2 root 5 root 3. Plus the last thing squared, and root 3 squared is 3. And that is the expansion of the first bit. Then I've got a plus, and now let's do the expansion of the second bit. What have I got? The first thing squared, 5, plus 2 times everything, 2 root 5 root 3, plus the last thing squared, 3. And that is the expansion of the second bit. Okay. Well, 5 plus 3 is 8, minus root 5 times root 3 is 15, so I've got 2 root 15s. Plus 5 plus 3 is 8, plus 2 root 5 times root 3 is 15. These two things will cancel each other out. I get 8 plus 8, I get 16. Now, let's have a go at 2h. Now 2h has a nasty root 2 out the front, and we've got 2 root 5 minus 3 root 3 squared plus root 6 plus root 5 squared. Okay, well, I'm just going to expand that, and I'm going to leave that root 2 out the front. So I'm going to need a set of parentheses here. So it's the first thing squared. Well, 2 squared is 4, root 5 squared is 5, 4 times 5 is 20. Minus 2 times everything, 2 times 2 root 5 times 3 root 3. Plus the last thing squared. 3 squared is 9. Root 3 squared is 3. 3 nines are 27. Whew. And that is the expansion of that first one. Let's go to the next bit. And we'll expand this. What have I got? First thing squared, or root 6 squared is 6, plus 2 times everything, 2 root 6 root 5, plus the last thing squared is 5. And that is the expansion of the second bit. Let's tidy up the brackets. I'm still going to leave that root 2 out the front. 20 plus 27, 47. 2 times 2 is 4, times 3 is 12. Root 5 times root 3 is root 15. Let's tidy up these brackets. 6 plus 5, 11, plus 2, root 6 times root 5 is root 30. Now I've got this. I've got this bracket. I've got to multiply that by that and that by that. So I get 47 root 2. Not doing anything with that. I can't see anything easy to do with that. Minus 12. Now root 2 times root 15 is root 30. And here I just open up the brackets. I get 11 plus 2 root 30. Well, I've got minus 12 root 30s. I'm going to add 2 root 30s. So I'm going to get 47 root 2, can't do anything with that, minus 10 root 30s plus 11. And that's it. Woohoo! So apart from that stuff up there, with this 9, when I did 3 times 3 and got 6, that should be all good. And that is the last couple of questions of 11, 12 and 14.